Good morning friends, welcome to Parnika's Tutorials YouTube channel. In the last video, I have discussed what is a binary tree and how can we represent the binary tree using arrays and using linked list I have discussed. I hope you have watched that video. If you did not watch that video or if you does not know those concepts, I request you to go back and watch that video and come back to this video for better understanding. In this video, I want to discuss various types of the binary trees. The binary trees are broadly classified into 5 types. One is strict binary tree, next one is complete binary tree, perfect binary tree, balanced binary tree, and degenerate binary tree. First, let me write all the various types, then I will discuss each one in detail. The binary trees can be classified as a strict binary tree, or it can be a full binary tree, or it can be a proper binary tree. Okay, and a binary tree can also be called as complete binary tree, and it can be a perfect binary tree. It can be degenerate binary tree, and it can be a balanced binary tree. So these are the 5 types of binary trees. Now each one we will discuss in detail. We have strict binary tree, complete binary tree, perfect, degenerate, and balanced binary tree. First let me discuss about what is a strict binary tree. Strict, or even you can call it as a full binary tree, or you can call it as a proper binary tree. When I will call a binary tree as a strict binary tree is that every node can have 0 children or it can have 2 children. Such binary tree I will call it as a strict binary tree. A node can have either 0 children or it can have 2 children. What is the restriction we are keeping? A node cannot have a single child. What is a binary tree? A binary tree is a tree where each node can have at most 2 children. At most 2 means it can have 0 children, 1 children, or 2 children. That one we will call it as a binary tree. But what is the restriction we are keeping in the strict binary tree? A node can have either 0 children or it can have 2 children. Now let me give an example for the strict binary tree. Now this is a node. It can have 2 children. Okay. So can I call this as a strict binary tree? Yes, this node is having 2 children, this node is having 0 children, this node is having 0 children. So this binary tree I can call as a strict binary tree. Now can I call this one as a strict binary tree? Yes, I can call it because this node is also having 2 children, this node is having 0 children. Now can I call this one as a strict binary tree? Yes, I can call this one as a strict binary tree. Now can I call this one as a strict binary tree? No, I cannot call this binary tree. This is a binary tree, but this is not a strict binary tree because this node is having single child. So this is not a strict binary tree. If I add one more node here, now I can call this as a strict binary tree. So I hope you have understood what is a strict binary tree. Now let me discuss what is a complete binary tree. We will discuss about complete binary tree. A complete binary tree, when I can call a binary tree as a complete binary tree is that all the levels are full except the last level. In the last level, the elements start filling from left to right. I hope with this definition you have understood. If you did not understand with the definition, let me discuss with an examples. Now, let's take that all the levels are full means this node can have at most 2 children. Am I right or wrong? So if I write like this, now I can call this one as a complete binary tree. Is it clear? Suppose if I have one more child, the left child should be there, means this node, if it had to have a child, it should be there in the left. So now I can call this as a complete binary tree. See it. This is the level 0, level 1. Level 1 is full. Now coming to the level 2, the elements are start filling from left to right. Suppose if I want to add one more element, that element should be there here. Now I can call this one as a complete binary tree. Now if I want to add one more element, it should be there here. Now can you tell me this is a strict binary tree? No, this is not a strict binary tree. Can it be a complete binary tree? Yes, I can call this as a complete binary tree because this level and this level is full, and in this level if you are adding the elements, it is there from left to right. Now if you want to add one more element, you can add here. Now this one I can call it as a strict binary tree, I can call it as a complete binary tree. Now if I want to add one more node, I should add from the left to right. Now can you tell me this is a complete binary tree? This is not a strict binary tree and it is not a complete binary tree. Why? Because first it is not a strict binary tree because here this node is having single child, this node is also having single child. Coming to the complete binary tree, this one should be there here because if you are adding the nodes at the last level, it should be added from left to right. Okay. Suppose if I add this one here, now I can call this as a complete binary tree. So I hope you have understood what is a complete binary tree. In all the levels, the nodes are full. In the last level, the elements or the nodes should be filled from left to right. Then such tree we can call it as a complete binary tree. So we have discussed about the strict binary tree. We have discussed about the complete binary tree. Let me discuss about what is a perfect binary tree. I hope it is visible for you, or let me erase it properly. Perfect binary tree. Now when I can call a binary tree as a perfect binary tree is that all the internal nodes will have two children and all the leaves will be there at the same level. Now what is the meaning of that one? I will discuss with an example. Now all the internal nodes, I hope you have understood what is a leaf nodes and the internal nodes. Let me discuss with a simple example. Now in this binary tree, this is the root node and these are the leaf nodes. Now the nodes other than the leaf nodes can be called as a internal node. Suppose let's take that. Now this is the binary tree. Just I am discussing about the leaf nodes and internal nodes. This is a leaf node. When I can call a node as a leaf node, if it does not have any children, then I will call it as a leaf node. And this is a leaf node. And other nodes other than the leaf nodes will be called as internal nodes. This one and this one we will call it as the internal nodes. Now coming to the perfect binary tree, all the internal nodes will have two children and all the leaves in the same level it should be there. Now can you tell me whether it is a perfect binary tree? Now if you see what are the leaves are there, this leaf and this leaf. This leaf is in this level and this leaf is in this level. So I cannot call this as a perfect binary tree. Now look at it. Now can I call this as a perfect binary tree? You look at. What are the internal nodes? This is an internal node. This one and this one are the internal nodes. All the internal nodes are having two children. This one is having two children. This one is having two children. This one is having two children. What are the leaf nodes? This one is a leaf node. This one is a leaf. This one, this one. Now if you look at all the leaf nodes are at the same level. Now this one I can call it as a perfect binary tree. Can I call this one as a strict binary tree? Yes, this one I can call it as a strict binary tree. Can I call this as a complete binary tree? Yes, I can call this one as a complete binary tree. Now let's take that I am adding one more element here. Now can this be a strict binary tree? No, it cannot be a strict binary tree because this node is having single child. Can it be a complete binary tree? Yes, I can call this one as a complete binary tree because all the levels are full except the last level, and the last level the nodes are added from left to right. Now, can I call this as a perfect binary tree? No, I cannot call this as a perfect binary tree. Why? This is an internal node, this one is internal node, this one is internal node, and even this as an internal node. First thing that this internal node is not having two childrens, and another thing is that this is the leaf node, this is the leaf node, this is the leaf node, and this is the leaf node. If you look at all the leaf nodes are not at the same level. Now similarly, can I call this one as a perfect binary tree or not? Yes, I can call this one as a perfect binary tree. How? If you look at it, all the internal nodes will have two children. This is an internal node having two children. This is an internal node having two children. This is an internal node having two children. And even all these internal nodes having two children, and all the leaves are at the same level. So I can call this one as a perfect binary. Now, a lot of students may get the doubt, sir, can this be a perfect binary tree? All the leaves are at the same level because this is not a leaf node. Now, but if you look at the second property, all the internal nodes should be having two children. So, whereas this is an internal node is not having two children, so this is not a perfect binary tree. So, I hope you have understood what is a perfect binary tree. Now, let me discuss about the degenerate binary tree. A binary tree, when I can call it as a degenerate binary tree, is that all the internal nodes having single child. Okay, what is meant by all the internal nodes having single child is that suppose this is a node, it will have a single child, this one will have a single child, this one have a single child, and this one will have a single child. Look at it, all the internal nodes. What are the internal nodes here? This is a leaf node. First you need to identify what is the leaf nodes, and rest of the nodes we can call it as an internal node. This is an internal node, this is an internal node, this is also an internal node, this is root node and also internal node. Now if you look at all the internal nodes, this one is having a single child, this one is having a single child. Whether it is a left child or right child, we does not bother, but the internal node should have only single child. This one is also having single child, but this is a leaf node, so no problem. So this one I can call it as a degenerate binary tree. Now, can I call this one as a degenerate binary tree? Yes, this one I can call it as a degenerate binary tree, and even it is called as left skewed binary tree also. Now, can I call this one as a degenerate binary tree? Yes, I can call this one as a degenerate binary tree because all the internal nodes are having single child, and even it is called as right skewed binary tree. So, with this one, I hope you have understood what is a degenerate binary tree. Now, let me discuss the last one, which is a balanced binary tree. Okay, now let me discuss what is the balanced binary tree. One second. Balanced binary tree we will discuss. Now, if you need to understand what is the balanced binary tree, first you need to know what is a balanced factor. Balanced factor of a node balance factor, not balanced factor. Balance factor is equal to height of the left subtree minus height of the right subtree. Now let me discuss with a simple example. This one, we having the nodes like this. Now can I call this as a binary tree? Yes, this one I can call it as a binary tree. Now if I want to compute the balance factor of this node, you need to check the height of the left subtree. Height of the left subtree is 1 and height of the right subtree is also 1. So 1 minus 1 is equal to 0. Are you able to understand? Similarly, if you want to compute the balance factor of this node, height of the left subtree is 0, height of the right subtree is 0. So 0 minus 0, you will get 0. Similarly, the balance factor of this one is height of the left subtree is 0, height of the right subtree is 0. So 0 minus 0 is 0. Are you able to understand? Let me discuss with few more examples. Suppose let's take that. The balance factor of this node, height of the left subtree is 1, 2, 3. So height of the left subtree is 3, height of the right subtree is 2. So 3 minus 2 is equal to 1. So balancing factor of this root node is 1. Balancing factor of this one is 2 minus 1, which is 1. And balance factor of this one is 1 minus 1, which is equal to 0. And balancing factor of this node is 1 minus 0 will be 1 and this one will be 0, 0, 0, 0. Remember one thing, the balancing factor of the leaf nodes will be always equal to 0 because leaf node meaning is what? It does not have the left child, it does not have the right child. If it does not have the left child, the height of the left subtree is 0 and height of the right subtree is 0. So 0 minus 0 is 0 only. Now when I will call it as a binary tree, as a balanced binary tree, is that if all the nodes balancing factor, if it is there from minus 1, 0 or 1, then I will call it as a balanced binary tree. If all the nodes are having the balanced factor as 0, then I will call it as perfect balanced binary tree. Are you able to understand? If all the nodes, suppose let's take that. If you look at here, all the nodes having the balancing factor 0, then I will call it as perfect balanced binary tree. If it is minus 1, 0 or 1, if each node balancing factor is in the range from minus 1, 0, 1, then I can call them as almost perfect balanced binary tree. So I hope with this one you have understood various types of binary trees. If you still have any doubts related to these concepts, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.